Assalamualaikum and very good morning to teacher and friends. Today I want to present about the late night. For the introduction, free fall. A free fall feeling object is defined as an object that is falling solid to the force of gravity on it. Whenever an item is just affected by gravity, this refers to as a free fall. Gravity acceleration an item in free fall, causing it to accelerate faster. A major example of a uniformly acceleration movement is a free fall. The result of it is body regardless of their shape, nature, and weight fall equally quick. The amount of acceleration of free fall is g equal 9.81 meter per second cube. The final speed of a free fall body depends on the weight which has fallen. The final speed of a free fallen body depends on the weight which has fallen. For example, is formula for the final speed is v equal plus square root 2 multiply g multiply h. For the intro for the moment of inertia, moment inertia is a quantitative measure of the rotational inertia of the body in physical. The body resistant to having the speed of rotation around an axis of rotation changed by the application of a torsion is shown by the body in linear motion. The moment of inertia is comparable to the concept of mass. According a new law of inertia. For the example, for the formula for the this J equal 1/2 m multiply r squared. And then the acceleration is calculated as follow. A acceleration equal mg sine alpha r squared over j. And the objective of this experiment are to determine first the mass moment of inertia by rolling experiment. Second, the mass moment of inertia by pendulum experiment. And third, the law of falling body on an inclined plane. That's all for me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Fazli bin Zakaria. Today, I with my partner to make a replicate experiment about rolling this on the inclined plane. This is the apparatus. This brick stand for adjustment stand. This is for large disc. This is for small disc. This is to measure the plane, and this is for the stopwatch. This is plane that is about 750 millimeter. Next, I pass to my partner to discuss to present the procedure of this experiment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif, and I am going to present the experiment, the replicate experiment. Firstly, we must adjust the component like this. This is stand, and the plane will be inclined. Firstly, we must take a measure from here using this tape, and measure from this place and to this bottom, and then we can calculate the angle of this plane. And next, we're going to take the small disc from here by using the stopwatch, and at this place we'll stop the stopwatch. Okay, I am going to start now. Okay, this I got about 1 minute, about 1 second, bit like that. And then we change to the touch disc from here to here, like the others, like the small disc, and take the measurement. Next, we will change the measurement by lower the brick, and then we take the experiment like before, from here to here until one brick. Thank you.
Assalamualaikum and hello everyone. My name is Muhammad Amin bin Muhammad Amar. My metric ID is MA18105. So this is our result for test 1. So the distance for our experiment is 750 millimeter. So there are 6 number of bricks with the angle inclination of until 6 degree. So and then the data was obtained 3 times and the mean value was calculated. We carry out the experiment 3 times. We repeat it. So from here you can see that the mean is the first, second and third time we divided, we plus and we divided by 3 and we get the 1.41 second. So the next one is the table 2, which is the large disk. We calculate the table for roll time distance of 750 millimeter. The equations that we use is the J, which is the mass moment of inertia. We calculate it by equals to 1 over 2 times with the mass and the radius of the disk in m, which is SI unit, meter, r square. So the next one is the acceleration, which is the mg sine alpha r square over j, which is the mass times with the gravity and times with the sine, and the alpha is the inclined angle and the r square is the radius of roll, which is in meter, over the j. J is the mass moment of inertia. And then the next one is the t, which is square root of 2s over a, which is the s is the distance over the a is the acceleration. So and then the deviation is we calculate it by formula measured time minus the calculated time, and then we over it with calculated time and we times it with 100. So okay, so next is the small disk. For this one we also use the same equation, which is the J is equals to 1 over 2 mr square, which is the mass times with the radius of the disk, m square, and then the acceleration is also the same thing, mg sine alpha r square over j. It is the same formula that we use from the large disk. Okay, and then this is the result that we get from test 2, which is the equation that we use is t mean. We get the t mean, which is the t1 plus t2 plus t3 when we divided it by 3, and then we get the 2.58 second, which is for the large disk. And so the next one is how do we get the radian, how do we get the angular velocity. So we obtain the angular velocity by first we calculate the f, which is the frequency, 1 over the t period. Our period is the t mean, which is the 2.58 second, and then we get the frequency of 0.388. Next we do the moment of inertia, which is the Js calculation, which is the m dot g dot s over omega square minus with meter per second square m, which is mass second square. So we calculate it and we get the value of 2.028 kilogram meter square. So that is all for me, and thank you.
Hi, my name is Inta Fazana, numerator MA18138. So I will continue with the discussion. So question number 1 is how to adjust the angle of inclination. So we rotate the height of adjuster until the chosen angle value is shown. So I'll continue with the question 2. What is the purpose of angulometer? So to determine the angle of inclination, we must ensure that we obtain the accurate reading in order to eliminate the inaccuracy. So question number 3 is, can you give an alternative method to measure the angle of inclination? So our answer is we may also use the trigonometry, the inclinometer, and a digital protractor to us to determine the angle of inclination. So number 4 is how to make a precise alignment for this experiment. Before we start the experiment, we have to make sure the 3 bubbles are in the center by adjusting the height adjustment spindle. So number 5 is why the angle higher than 7 degree cannot be used in this experiment. So when the angle is more than 7 degree or 7 degree, the travel time and the distance are being reduced. So number 6 is give the definition of a free fall theory which discovered by Galileo. So because the item falls with the same acceleration from start to finish and equal time interval, the speed increase is required. So question number 7, it gives the factor that cause free falling body. So we consider the air resistance in proportion to the body's weight. So question number 8, what is the relation between angle of inclination and the rolling disc? So basically we use the formula like written, the angle of inclination is related to the disc acceleration. Explain the term inertia. The bodies that, unless act upon by external factor that modify their condition, will continue to be at rest or in motion along a straight line. So I continue with the question number 10. Why repeatability of the measurement is important? The importance of measurement repeatability is reduced measurement error when performing the experiment. So basically, this is the free body diagram for this roll on inclined plane. And question number 12, why deviation occur between calculated and measured value? Measurement error and the impact of friction between the disc shaft and track cause the deviation in the measured value. So the last question is how we suggest to improve of this experiment in the computation. The friction between two surfaces should be taken into the calculation. So that's all from me. Thank you.